Okay, hi everyone. So today we are going to work on graphing a system of equations to solve for that system. And we're going to start with word problems. So we've been working with word problems the last couple of days. Hopefully, as you've been practicing with word problems, you've been feeling a little more confident, seeing that it is not impossible, but practice is super important to get some fluency going, okay? So let's go ahead and read through this. And we're going to read through it and we're going to work it out. Hazel is training for a triathlon and needs to swim a certain distance for today's workout. All right. If she swims at the rec center pool, she will complete a 100-yard swim warm-up and then swim laps in a lane that is 30 yards long. Okay. So she's going to do a warm-up lap and then she's going to start swimming 30-yard long laps. If Hazel swims at an indoor pool, okay, now this is a different pool. Okay. So here's the thing. The rec center, and then now we have an indoor pool. That's a different pool at our gym. She will complete a 300-yard warm-up. Wow, okay. This girl is awesome. 300-yard warm-up. And her laps now consist of 20 yards per lap. If Hazel swims the correct number of laps, she can complete the same distance in either pool. How many laps will this take? So this is super wordy, a lot of stuff going on. We can see that the chart gave us laps. That's almost like our x value, and our distance is our y value. So how far have we really swam? So let's give ourselves a equation for our first one. We have 100 yards, so we for sure have to warm up with 100 yards. And then we're going to add 30 yards per lap. And I'll use the word, let's use the letter capital L. And this is equal to our total distance. Okay, capital D. So this is pretty much what we're graphing. We're graphing this equation here. Let's make sure this makes sense. If I swam one lap, that means it's going to be 30 yards, right? So they went 130 yards. If I swam two laps, that would be 2 times 30 is 60. That would be 160 yards. That kind of makes sense to you? Yeah? So let's rewrite this as D is equal to 30L plus 100. That means this is our y equals to mx plus b equation, where y is now our result, our distance, our laps is our x value, and then we have a slope of 30 because this is what's changing every single lap, and our d value, our b value here is 100. That's what we're going to start off at. Okay. So I'm going to go ahead and try graphing this, and you tell me if it's going to be hard or not. The b value is 100. Can you all see this is 100 right here? So we put a dot at 100. And the slope is 30 per lap. So 30 per lap. So 30 per lap would look something like 30 per lap. And that's going to be kind of hard to do. So instead, looking at this graph here, I want you guys to notice that this is counting by 5s, and this is counting by 10s, yes? Counting by 5s and 10s. So our slope here, this is the tricky part. If our slope is 30, right, 30 yards per lap, that's how we're looking at 30 yards per lap. And here's how I think it's going to be easiest to graph it. I need to somehow make this conform to this graph here. And I don't see 1, 2, 3, 4, 5, right? That's kind of going to be hard to draw. But they do have 5s and 10s. So how many yards would she swim in 5 laps? How many yards would she swim in 10 laps? So this could be written as 30 yards times 10 is 300 yards for every 10 laps. Now if you take a look at how I changed the slope here to make this a lot more easily graphable, so we can fit our little chart here, we have to go 300 for every 10 laps. Now, I want you guys to see that this is actually 100, 200, 300. That's actually pretty easy to do. If I tried counting by 1 yard at a time, 30 yards was going to be hard to hit. So please take a look here. I multiplied my slope so that it would be easy to graph. So we're looking at 300, 1, 2, 3 for every 100. And this is our first line. Oh, sorry, that's wrong. I put 5, right? For every 10. And this is our slope here. Okay. Right, so let's try another one here. Let's graph the second one. The second one said if I swam 300 yards, and then for every lap she does at the second pool, the indoor pool, that'd be 20 laps. Rewriting this as D is equal to 20L plus 300. We see this as y equals to mx plus b. Right, and this idea here, we're being flexible. We're making sure we understand the ideas, not just memorizing the variables. Our y is our distance. Our m is my slope. My x is my number of laps that's changing. And our constant, our y-intercept is going to be 300 here. Right? All right, so we can start at 300. So my next graph will be at 300. Here's 300. Oops. 300. And then what's the slope? The slope is 20 over 20 laps, 20 yards per lap. Now the problem with 20 yards per lap is I can't graph these one laps, right? We can't just say one lap at a time. So I'm going to multiply this by 10 also. So it's going to be 200 yards for every 10 laps. And that's our slope, 200 over 10. So 100, 200 over 10. So they're going to somehow cross way over there. All right. So my terrible graphing, I mean, I could continue to go 1, 2 over 1, 2, 1, 2 over 1, 2. So these are my major dots. And we can continue my terrible graphing, but let's go ahead and jump back to IXL. And we can graph it using IXL. So our first one, we said, let's go ahead and look at the colors. For the rec gym, I'm going to pick that blue color. We said our starting value was going to be 100. So I put dot 100, and the slope is 30 over 1, or 300 over 10. So 1, 2, 3 over 10. That's my first line. The gym is going to be 300. And the slope for that was 20 over 1, or 200 over 10. 100, 200 over 10. And you can see where they meet. Right? They meet right here at 20 over, at 700 distance and laps of 20. So 20 laps will give them 700. So if she did 20 laps at either a pool, it would give her the same distance overall. So it doesn't matter which one she goes into. Oops. This was, sorry, I clicked on accident and messed it up. So we said it was 300 and up to over, okay, like that. All right. So let's go ahead and write it in our answer. Our answer is they would be the same exactly at 20 laps. Great work. Okay, so we're going to do the same thing for these two. For the next two problems, I want to write it out. And we have, okay. Last Wednesday, two friends met up after school to read the book they were both assigned in lecture class. Hansen can read 2 pages per minute, and he already read 40 pages. So this is going to be pretty easy. He already read 40 pages, and he can read 2 pages per minute. I use little m here, and this will probably be our total. Okay, T for total. Or you can say P for pages if you want to. Let's use P for pages, because that's what our graph shows. And the second kid, Logan, who has a reading speed of 4 pages per minute, okay, 4 pages per minute, but he already read 30 pages. And that would give us a number total. Eventually, they have read the same number of pages. How many pages did each of them read? Eventually, they have read the same number of pages. How many pages did each of them read? Okay, so how many pages did they read total? So what is the total number of pages they read so that this will be equal, right? So we can go ahead and graph these. The first one is at 40, the slope of 2 pages per minute. Now, if you look at this as 1, 2, 3, 4, hey, 2 pages per minute. We can do 2 pages per minute. But the problem, do you see how this is kind of small to see? 2 pages per minute? That's going to be hard to hit. So maybe I can multiply this by a number that makes it a lot easier to look at here. Let's hit the 10 mark. So how can I make 2 become 10? We would have to multiply by 5, right? So let's rewrite the slope. The slope for my first problem would be 2 over 1 is the same as 10 over 5. Are you guys okay with 10 over 5? So if I go up 10, that's 50, and then I can go over 5 minutes. 1, 2, 3, 4, 5. And that's what this line looks like. Again, we're trying to manipulate my slope so I can graph that nicely in the equation. And the way we do that is we just multiply our slope by a number that would end up fitting nicely on this graph. So let's do that again. Just to reiterate, if I write my slope is 2 per minute, 2 over 1. Look, I can't graph 2 over 1, right? It would be too hard to graph. I don't think Excel will even let me do that. So I can either graph 10 or 20. And I think 10 is going to be easier for me. How can I get 2 to become 10? I multiply both sides by 5. Times 5 times 5, we end up with 10 over 5. Now, I'm not taking 1, 2, 3, 4. I'm not doing 10 this way. Look, 10 is already written right here. Every step is actually already given as 10. Over 5, every step here is as 1. So I'm going to hit 1, 2, 3, 4, 5. That's why this can be a little bit more tricky. All right, let's look at our next child. That's going to be 30. He's going to start way over here at 30 degrees. 30. But his slope is 4 pages per minute. Now the problem is, again, I can't count 1, 2, 3, 4, right? And this would be 1, 2, 3, 4. It's actually not 4, but 40. So for me, to get from 4 to a nice number, well, 4 can't get to 10, but 4 can get to 20. 4 times what is 20? 4 times what is 20? 4 times 5 is 20. So I'm going to multiply the bottom and top by 5. That's going to be 20 over 5. So the slope of the next line would be 20, 1, 10, 20 over 1, 2, 3, 4, 5. Turns out that's where they meet. This is one reason why I don't think graphing is always the best technique for solving a system of equations. It is visually appealing and we can see where they meet. So at 5 minutes, both students would have read 50 pages. Oops. Oh, darn it. 50 pages. Okay, so both kids after 5 minutes would have read 50 pages total. Let's see if that makes sense. If the first kid reads 2 pages per minute and he already read 40 pages, so he read 40 pages already, and then he reads another 5 minutes. 5 times 2 is 10. He read a total of 50 pages. Let's look at the second child. He already read 30 pages, but he reads faster. And he reads 4 pages per minute. And 4 times 5 means he read 20 pages also. That means he has a total of 50 pages read total. So these kids both read 50 pages. Just to verify. So let's go ahead and go back and graph this. Now again, this is going to be a little tough, but let's just take it what we have. So first thing I want you guys to notice is that we have 40 pages. So you can actually just start off here and say, hey, 40 pages. That's my first dot. Now I can't go up 2, right? It's impossible for me to go up 2. It actually unclicks it. If you guys can see, it actually unclicks it. So, but we said we're going to hit this, we're going to multiply this 2 by 5 to get 10. And then we're going to move over 5 steps. 1, 2, 3, 4, 5. Okay, 5 steps over. The second one was 30. And the slope we said was 4 over 1. But we said we can't graph 4 over 1. So we multiplied them by 5 to get 20. So 10, 20. And we said the slope was 1, 2, 3, 4, 5. So the answer is the question is overall, how many pages, again, how many pages did the kids read? They read a total of 40 pages. No, sorry, 50 pages total, 50 pages. I'm writing 50 here. All right. So this IXL here will be a little harder. I think I only put this up to 70. So this is really a learning activity. I've done 2 questions. I'm already at 36. Okay, so you're going to gain a lot of points for every one you get right. So we'll do 2 more of these just to make sure you guys are comfortable. Okay? Shelly is going to ship some gifts to family members, and she is considering 2 shipping companies. The first shipping company charges a fee of $20 to ship a medium box, so $20 for a medium box, plus $2 per pound. And this is our total cost. Our next shipping company, let's go ahead and read this, is charging $10 for the same size box, in addition of $3 per pound. And you know what? This is actually how shipping companies charge. They charge you for the size of the container. What if you have a huge container, but it weighs only a pound, right? Versus a small container that weighs 50 pounds, right? So they actually charge by the container size and by the weight. So every container size gets a different weight. I learned the other day that they actually used to mail babies, like little kids and babies. So mail carriers used to carry these babies across borders because it was cheaper to pay postage on these kids than to actually pay for a train ride. Like, no joke. They stopped doing that. Okay, so we have 2 equations here, and let's see if we can graph it. The first equation is, we're going to start at 20. Okay, 20. But again, the slope is 2 over 1. 1, 2 over 1. And then so we can't graph it. So instead, we're going to multiply our slope 2 over 1 by some number so that we can have a nice hit. So let's try it by 10. If I just, by 5. Let's do by 5. So if I do by 5, multiply them by 5, we end up with the slope of 10 over 5. Is the slope of 10 over 5 the same as a slope of 2? Yes, it is. Right? 10 divided by 5 is still 2. We're just multiplying it so it's easy for us to graph, so it can fit on these lines. Let's see if this would be an okay one, or do we have to pick a larger number? If I raise 10, I have to run 5. Now, I want you guys to notice that every step here is 5, 5, 5, 5. So if I go up 10, I need to just go over 1 step over, and that would be 10 over 5. And how did I do this? Because every tick mark here, this is actually 10, and every tick mark to the right is actually 5. 10 over 5. Now, why did I have to change it? Remember, 2 over 1, we couldn't graph 2 over 1, it was too small. So I decided to multiply by a number to make this fit. What if I decided to multiply by 10 instead? Sure. 2 times 10 over 1 times 10. This would have given us 20 over 10. Would this also have been graphable? Let's take a look. I'm going to use a different mark line here. So from our point 20, if I went up 20 over 10, which would have been 2 marks, actually that would have been good. The only problem is my previous line was quite terrible. This would have been A-okay. Oh gosh, it's so terrible. It takes so much time for me to take out a ruler. I think you guys feel the same way. Right? So whether I use 10 over 5 or 20 over 10, it was still giving us the same value. Right, let's try the next one. Let's do the second company. The second company we said was starting at 10, and the slope was 3. Oh my gosh. 3 over 1. I can't graph 3. 1, 2, 3. No way. So the trick is trying to multiply 3 by something that would make this fit. Now, if I say 3 times 5, that would be 15. And 15 isn't a nice tick mark here, is it? So let's do 3 times 10. So 3 over 1 and 10 over 1 times 10. This will become 30 over 10. I can graph these. 30 and 10. These are tick marks that work for me. So from here, let's count 30. 10, 20, 30 over 5, 10. And we have our second line equation. And we can see where they meet. So the trick here is I'm changing my slope to fit the graph, so the graph is accessible to me. I'm going to tell you again, graphing is not the best way to solve a system of equations. Right? right? And we showed that before, it's not the best way, especially in these word problem styles or in many styles where the graph itself, the slope doesn't match nicely to the equation we came up with. So in this case, I had to change the slope so it would be easy to graph. Okay, let's go ahead and graph these. So for the first one, my first company, we started to say this was a $20 shipping cost to start, $20, and the slope was $2 per pound. But we couldn't graph 2, so we said, hey, I can multiply this by 5. 5 times 2 is 10 over 5. And each of these steps are 5. My second company, the initial cost was $10, 3 pounds, $3 per pound, but we couldn't graph 3, so we said multiply this by 10 to make our lives easier. 3 times 10 is 30, 10, 20, 30, divided by 1 times 10 is 10. And we can see that after 10 pounds, the price would be exactly the same. So the idea is if you were under 10 pounds, the second company, this green color company, would have been cheaper, but after 10 pounds, the green company would be more expensive. And vice versa. The blue company would initially be more expensive for lightweights, but as this got more heavy, the blue company would have been cheaper overall. And these are super important ideas to be able to wrap your heads around. Why would you choose one credit card company versus another credit card company, one bank over another bank? The promotions might be great, but in the long run, how are we going to make out here? So the weight they said is going to be 10 pounds. Okay, we're going to do one more question here. Okay, Nora and Barry are making presentations for our classroom. Nora's slideshow starts with a verbal introduction for 15 seconds long. So we know she's going to start off 15 seconds long. And then each slide is left up for 4 seconds. So plus 4 seconds per slide is equal to the number of seconds total. I'm going to use T for time in the end. Barry leaves each slide, leaves each slide on for 5 seconds and has an introduction of 10 seconds. So his is spun out. He has 10 seconds to start plus 5 seconds per slide. And that's his total time. This is Nora and this is Barry. All right, so Nora and Barry notice that their presentations have both the same number of slides and the same duration. How long is each presentation? So we want to figure out at what point do they have the same number of slides and the same number of time. Okay, the S and T are the same. And that will be some meeting point, right? When S and T, they're going to meet at some point here. So let's go ahead and start off with our first graph, 15. We're starting at 15. But if you look at the slope, it's going to be 4. I don't want to count 4. That doesn't work for me. So I need to somehow change the number 4 to a nice 10 number, 5 or 10 number. So we're going to say 4 times 5 would give me 20, right? So I'm going to write this over 1 and 5. This is going to be 5. Is 20 divided by 5 the same as 4? Yes, it is. So I changed it so I could fit it on this graph. And I could count 1, 2, 3, 4, 5. We can do that. The spacing and the notation for our x values, our slide values, can fit that. So let's go count it. 10, 20, is that right? Nope. That was counted by 5. So this is 10, 20, right? 15 plus 20 is 35. And our x, our run, is 1, 2, 3, 4, 5. Put a dot there. All right, let's take a look at our next one. Let's switch colors here. Our slope, our starting value is going to be 10 here. But our slope is 5. Now, I could count 5, can't I? 5 over 1. We can do that. But does it fit? You tell me. From 10 to the next tick mark, that is 5. 10, 15, 20, right? That does fit. So what we're going to do is go ahead and draw that out again. 5 and then 1. That does fit. So we actually don't have to change that second slope value. Because lucky for us, it does fit. So 5 and 10. Let's take a look at where these guys are going to run into each other. And you can see that these lines both run in about, it looks like 5 slides at 35 minutes in time. 5 slides on 35 minutes in time. Let's go ahead and graph this on Desmos and see how that goes. So now Desmos on IXL. So our first one was, we started at 15 seconds. We couldn't graph 4 seconds per slide, but we said we're going to multiply that by 5 to 20. So 10, oops, that wasn't 10. 10, 20, and then 1, 2, 3, 4, 5. That's our first. Our second one for Barry, we're going to start off at 10 seconds, and the slides are going to be 5 minutes per slide. And that worked. We were able to fit the graph nicely onto these lines, onto the scale. So in the end, we have 5 slides, right? This looks like 5 slides. 5 slides and 35 seconds total. So the question is, how many seconds total? We're going to write 35. Okay, that's it. We did 4 questions and we're at 60% already. Okay. And your goals today is to get up to 70, and you're done. But please take your time making sure you can understand how to set up the equations, as well as changing the slope to match the grids on this chart that's given. Okay, change to match the scale.